David is our technical director. He's a former student from Athens State, but he worked at a international paper company, I think it was here, until he got lucky enough to retire and stay home. This is one of my students in our aerospace systems management program. This is Ryan Frost. He transferred up from one of our two-year colleges. He's a CAD designer and he's learning electronics. He's going to be working our software issues for our satellite project and among other things. So they're here today, and we're going to, in a few minutes, after I give a short overview there, we're going to demonstrate some of our engineering model hardware. So, Rich, I'm sorry for butting in like that, but I just thought I'd say hi since we're here and set up.
It's great. It's great stuff. And by the way, this is Dr. Wayne McCain from Athens State. He's well known from the SARA. He's given a lot of presentations at SARA meetings, and they're setting up a student CubeSat program that has to do with radio astronomy. So we're actually going to award him a grant that's already been approved, and so Sarah is technically pretty well involved in this project too. So he's going to give a full presentation on it, and so let me give a couple announcements first before Wayne goes into with his team that's going to give a presentation on. First, the Australia Drake's Lounge is next Friday evening, Eastern time. I think it's 7 or 8, but it's 9 o'clock Melbourne time is local time is when the actual thing is. So anybody that can be involved in that, I'll send out a notice probably tomorrow on the Australia Drake's Lounge. So look for that. We have submitted the aerial antenna book input. They love it. Right now, there's the editors are spending time reducing that down for the paper version. And then we're also going to have it published in a software. What we sent, which is a 100-page version of it, will be published separately in their compendium. The SARA Western Conference is on. It's going to be at the Owens Valley Radio Observatory in near Bishop, California. So Bishop, California is where we're going to hold the conference, and then we'll take buses out to the radio astronomy area March 17th, 18th.
Rich?
Yeah, go ahead.
I actually asked the observatory if we could hold the conference in the observatory conference room. And that was the plan. However, if I have to, I can arrange facilities in town. There is a neat conference center there. It's kind of pricey, but might be worth using anyway. But if I do that, the cost might go up.
Your call there, David.
So right now, the plan is to hold the conference at the observatory conference room south of Bishop.
Great.
And that's what I will work towards. And if I have to change the plan, so be it. But that's what's going on.
Great. And you still need a couple of people to do some papers for you, right?
I need lots of people to do lots of papers, please. I've had one confirmation, and I have a guest speaker lined up. But beyond that, I have lots of empty spots. So please work on your papers and get the new abstracts to me as fast as possible, because our timeline of this conference is a bit compressed right now, and I would appreciate all the help I can get. Thank you.
And you can do it remotely via Zoom if you can't make it physically.
Yes, this is a hybrid conference. This will be a hybrid conference, and we'll arrange for concurrent Zoom broadcasts of all sessions if you need to go that route. And I understand that people are still nervous about COVID, and we'll arrange for all of the help we can get in that score, and a reduced price for those who attend remotely. And I will get with you about that exact number a little later, but that's what's going on.
And Wayne, students are welcome to give a presentation if you want to give them a chance to do a presentation.
Absolutely. Students are very welcome.
Yes, sir. I'll mention that right away and get the schedule. Make sure we all know what the schedule is, and we'll probably submit at least 1 or 2 abstracts right away.
Excellent. Also, speaking of abstracts, the November-December journal is coming up. If anybody's going to give a paper or an observation report, I need those by 12 December, so I can get the journal out. We'll have some content to it. So that's the other call for papers going on. And by the way, if you do a journal article, you can also have that same article at the Western Conference. So don't assume that because you put one in, you can't do the other one. You can do them both, because it's always nice to have a presentation at the conference, even though you've already had it in the journal, or you have the conference and then you put it in the following journal. That's okay. Okay. Another thing, and I know Alex has on the Sarah listserv, Alex has some significant made headway on his Cantana feed, and I think all of you guys have either looked at that. I think we'll probably try to get a YouTube video made of that the next month or so, as soon as he gets cleared up. But that's another thing he's doing for a university, so they can have a hydrogen feed or a hydrogen capability. So I just want to give kudos to Alex on his work on that. All right. Anybody have any announcements quick before I put Wayne on for his presentation? Okay, I don't hear anything. Wayne, the floor is yours, and you are being recorded. So, and I'll edit it. We'll edit it. So if you take any bad input here, I'll edit it out. So just go for it, and we'll make it look good no matter what happens.
I'll try to contain myself. Also, I noticed there's a selection on Zoom where you can enhance the quality of your video feed, so you might turn that all the way up too.
Yeah, I'm not sure we can make each other look better, but anything helps, right?
That was my thought, anyways. All right, sir. I'm going to share a screen if that's agreeable with you guys. Let's see if I can find the one here. Show all windows. Undoubtedly, it's the one that I can't see here. Here we go. All right, everybody seeing that?
I see it, Dr. Wayne.
Okay, awesome. All right. So again, thank you for the opportunity, Rich, and all the members of Sarah there to give an overview of where we are. Some of you have seen this basic pitch for years now. We've been working on the project since about 2018, maybe was the first time I think we presented it at the concept at the Western Conference, and we've been going on the project for quite a while. As Rich said, we had applied for a grant earlier and got it approved, but we never claimed the money because we just didn't get the traction at the beginning that we felt like we needed. But over the last couple of years, we've really made a lot of progress. So this is an update of where we are. We may have another couple of people joining in the Zoom meeting. I shared the link with a couple of our other people. Brandy Wheeler, who's an employee at Aerojet Rocketdyne. She's our program director for the StemSat. Another project manager is Michelle Allen. I'm not sure they're going to be here today. Everybody's just getting back from church about this time. But David and Ryan are here, and of course, I'm happy to be able to give the presentation. So what I'm going to do is just give you an overview that we presented a couple of weeks ago down at Via Space in Cocoa, Florida. Via is our launch provider on the StemSat, and I'll tell you more about them as we go. As you see here, a big component of what we're doing at the university is our Athens State student branch of the American Institute of Aeronautics and Astronautics, AIAA. They're kind of the focal point of our student activity on this project, along with our new degree program you see up in the upper right-hand corner. Just this fall term, we have officially kicked off our new Bachelor's in Aerospace Systems Management program here at the university. We have a aviation concentration in that, and Ryan here is a student in that, in the space systems concentration. So all of those students are involved, and of course Sarah has been a major player, although we haven't communicated with Sarah much lately. We've always had you guys in the picture. So this was what we did a few weeks ago. We basically had like a quarterly status meeting with our people down in Florida, who's our launch provider. We went over our status. They have a new facility that they're just bringing online in Cocoa Beach area. We visited that. Also met with some folks from Brazil. Yes. Brazil. I had a bunch of students visiting, and so we're going to be working with them as well. So it's basically where we went. So for those of you, many of you on the presentation today haven't heard of Athens State University. We're a unique part of the Alabama university system. We are an upper division only institution. We start at the junior level and teach junior, senior classes, award a bachelor's degree for our students that transfer here from two-year institutions. And we also offer master's degree level curriculum. And I suspect over the next several years, we may offer a PhD program. We did it one time years ago, and so we're kind of getting back into that. But I teach out of the College of Business, which is a little bit unusual for aviation, management of technology, and aerospace systems, but that's kind of the way it's set up here. As a matter of fact, Auburn University has their aviation management program under the College of Business now, so it's not all that unusual. So that's Athens State. Back last summer, 2021, we signed a educational business agreement with Via Space. I was telling Rich, Via Space is where SpaceX was probably about 10 to 12 years ago. They've done suborbital launches. They've tested over 100 different propulsion systems, but they have not taken a vehicle into orbit yet. That's hopefully going to happen in the first or second quarter of this coming year. And then our satellite is currently manifested for one of their first orbital missions, which will be late next year, fourth quarter sometime. And based on our meeting a few weeks ago, we're going to be scheduled to deliver our flight hardware late November of next year for a mid-December launch date based on where we are on their manifest right now. But they have a unique, to some degree at least, rocket technology. They're using a 3D printed fuel grain made out of high-density polyethylene, and their oxidizer is liquid oxygen. So it's a very controllable, throttleable type system. And of course, they're touting the fact that it's a green rocket fuel. based on recycling of plastics and so forth. So anyways, they are, like I said, about where SpaceX was years ago. And if you guys have noticed, the everyday Rocketeer or Everyday Astronaut, I think is the website, Tim Dodd does a survey of all the launch companies. I was noticing the other days is over 100 new startup launch service providers in this wave of commercial space development that's taking place over the last few years. So Via Space is one of those. The picture here shows our president, a university president on the far left, Dr. Philip Way, myself, Jack Blood, the COO at the time, and then Rob Fabian is seated there. He is the Via Space CEO. So that happened last summer, a year ago. Okay, so most of you know the answers to this question. What is a CubeSat? We started out looking at a 1 unit size CubeSat, which is the smallest 4 by 4 by 4 inches size, about a 3-pound maximum weight. After meeting with Jeff from Moorhead University, he's one of our SARA members, they convinced us that really for long term, a 3-unit size spacecraft was the way to go. Allows you to have a much more robust power capability, power supply, more solar cells, so forth. So that's where we are. We are baselining as our primary spacecraft a 3-unit size, which is 4 by 4 by 12 inches. It's going to weigh about 11 pounds roughly. Totally self-contained. The rules are that it cannot interface directly electronically or for the most part physically with the main rocket payload. All we're going to have is a electrical connector that Via Space will hook up to arm and then eject the satellite from the dispenser. And we just learned at our meeting that we now have responsibility for our own dispenser. So we're working on a design and development of that, but it's going to be basically our version of a pea pod launcher, which is a little loaf of bread size sort of container that ejects the satellite based on a mechanical spring mechanism and so forth. So that's basically how we're going. So this is a model of our CubeSat up there in the upper right hand, done in part by one of our local 2-year colleges, Calhoun Community College, and Ryan here transferred after graduating from there. They did the basic external frame design and have been helping with the power supply enclosure and solar panel deployment and all those kinds of things. So this is an anatomy of a CubeSat mission. As I said, basically they do not interface directly with any of the main rocket hardware or software except for physically being on board. They're kind of like a piggyback second class passenger, so to speak, that gets deployed after the main paying customer or government supplier payload is deployed. Then the CubeSats are deployed. As a matter of fact, there were several CubeSats deployed just last few days on the Artemis mission that NASA launched out of Cape Canaveral, and SpaceX launches a lot of CubeSats. So do all the major providers through NASA. NASA, as you all know, I'm sure probably conduct a annual competition for slots in their system, their CubeSat deployment system. We elected to go with a private supplier, and it gives us a bit more latitude, although it's undoubtedly somewhat riskier, I think, but we're at least taking that into consideration. So our mission, I'm going to show you our slide. This is the scientific mission of it, and we've talked about this at several of the SARA conferences. We've had inputs from several SARA members. As a matter of fact, David Fields and some other people have contributed a lot to the overall concept of our mission, and David and some of his folks from the Knoxville area are currently working on receiver technology that might be used as one of our receivers in our payload. We're also working on another approach to a VLF receiver here internally at the university. But we are looking at receiving VLF signals that fall on the right-hand side of this chart that are blocked for the most part about below 10 megahertz, something in that range, and lower are blocked from the atmosphere, by the atmosphere rather, from the surface. So our scientific mission is to receive VLF signals, retransmit those on UHF that will penetrate the Earth's atmosphere, and then collect that data and try to make sense of it here on the ground. But that's, I have to point out, the science mission is not our primary mission, and I'll get more into that later. This is some of the things that we might expect to encounter at those VLF frequencies. As a matter of fact, we have funded a student at the University of North Alabama who is working on a research project to identify the types of VLF sources that we might expect to receive on our satellite mission. And we expect to get that report late this year or early next year. But some of the things you see listed here, all sorts of things ranging from cosmic dawn, epoch of reionization, first stars and galaxies, all the way back to the questionable Big Bang occurrence. Of course, we'll pick up CMEs from our sun and other signals that we can expect to hear. So should be interesting. We're not exactly sure of all the things we might be able to listen to, but we're looking forward to that science experiment part. But our primary mission is to involve students in the project, a space-based STEM activity for K through 12 and higher. We, as a matter of fact, the group you see here today, we briefed a group of third grade students, several classes at our local STEM Academy, Spark Academy here in Athens. We recently had a group up from one of our Alabama two-year colleges the week before last and briefed them. They're working with us. So our primary mission is to provide students with activities related to space as a STEM, science, technology, engineering, and math exercise, like mission planning, ground station operations, data reduction and correlation, hardware, software development, the building, testing, and even the launch operations. We're making the presentation today from a little miniature mission control center that we've set up here at the university. One of the courses we teach in our new program is mission planning and operations. We do mission simulations out of this little mission control room. For instance, we have simulated a 4-person human mission to Mars, segments of that, including the initial payload launches to bring the non-human payloads to Mars. We've done the crew landing event on Mars as part of our simulations. We've also simulated a a SpaceX Falcon Heavy launch, payload launch. So we do a good bit of stuff like that out of this room. So our intent is to use our mission control capability along with our StemSat project and run our mission from the university here. The secondary objective is the science experiment, basically, the VLF, LF receive. And then a secondary objective is the satellite health and welfare systems operations data downlink. And it's one of the things we're going to demonstrate here today to you. So primary mission, get kids involved. And we see so many intelligent and interested children in our area. You know, being an old timer myself, I worry sometimes that Generation Z or whatever we're up to these days may or may not be able to take the baton and run with it. But a lot of the students that we're seeing gives me faith that in spite of all the bad rap and distractions that the latest generation gets, that they are very capable and intelligent. And if we can stimulate their interest at an early age, we're probably going to be okay. That's my prayer anyway. And I think projects like this contribute to making that happen. If we can get students interested in things other than TikTok and playing on their phone all the time, I think that's probably a good thing. So that's one of our main goals here, is to do that. We do have lots of people working with us, not only Sarah, but we've, as I mentioned, we have the AIAA group, the Alabama, actually it's the greater North Alabama section of AIAA, has almost 1,000 members. We live near the rocket city of Huntsville, Alabama, with Marshall Space Flight Center. Hopefully the Space Command, Space Force will be centered here. We've got the U.S. Army Engineering and Development Center here, Missile Command here, Aviation here, U.S. Army Corps of Engineers. We've got every major aerospace contractor that I can think of has a major division here. We have the world's largest rocket plant under roof with United Launch Alliance. You can almost throw a rock from where we're sitting here and hit them down in Decatur. So we have a lot of advantages in our area, and a lot of those people are working with us and interested in helping this kind of a project. As I mentioned, our program director, Brandy Wheeler, is from the engineering department at Aerojet Rocketdyne. They were instrumental in part of the propulsion and such that's on the Artemis. They do lots of other things, but one of the contributors you see here at the top of this chart, Central Alabama Community College, their whole STEM organization is involved with us. Calhoun Community College, I mentioned, Florida Tech. We've collaborated with Vanderbilt, University of North Alabama, I mentioned, are helping us. Have a friend who's one of our adjunct instructors who runs the Museum of Arts and Sciences Technical Division over in Macon, Georgia. They're involved. We hope to get some participation with Green Bank going. The Alabama Academy of Science, I'm a former chair of the STEM committee for the AAS in the state of Alabama. They're involved. We're working closely with Alan Johnson and some of the other people at AMSAT. I mentioned Spark Academy. David Fields is from Rome State. Just a lot of people, and a lot of our group is not shown on this little chart. We have people in Hawaii, South Africa, Wales over in the United Kingdom, all over the country, and beginning to be a worldwide activity. And we're really excited about that. And as Rich and I were talking, we're going to need to coordinate a worldwide space network of listening stations that is going to be interesting to do as well. Our unit, as I mentioned, is a 3-unit size, 4x4 by 12 inches, has aluminum frame and side panels. A lot of the structure is also 3D printed. It's one of the contributions from Calhoun Community College, and here at the university, we print a lot of our, have printed a lot of our hardware that goes into it. We're going to have a deployable 4-wing solar panel array that will open up after the unit is deployed. We're using lithium-based batteries in our system now. We're going to make that final decision once we get some of our high and low temperature tests run. We're working with Adtran and Dynetics here in the Huntsville area to start environmental testing, including shake, rattle, and roll, shock testing, and vibration testing first part of the year. As I said, we basically have a receiver that's going to receive VLF signals and retransmit that on 70 centimeters. Our receiving and transmitting antennas are on opposite end of the spacecraft for some degree of oscillation. As a matter of fact, by working with via space, we're not held to the strict weight limits that you would be if we were part of the NASA CubeSat program. We have a little bit of latitude there. As a matter of fact, we have a Zoom conference on Tuesday where we're going to work with their trajectory people, talking about more details on the orbital parameters and the physical and electronic interfaces. And we're using as much off-the-shelf material. Some of our stuff we've even bought at Lowe's, so I can't feel bad about that, because as they used to say on Captain Kangaroo in the Stone Soup project that he read to children when I was a kid, it's whatever you can get, whatever people can contribute, and wherever you find it, put it to good use. So that's where we are. We do not use the word exploded in describing this view of our satellite, but this is a non-assembled expanded view. Let's call it that. This is an expanded view of the satellite. The battery pack is in the lower part of the spacecraft. The solar panels are nested along the side, along with the 70 centimeter antenna dipole is folded up under the solar panels. Once the solar panels deploy using a hot nichrome wire, brake wire deployment system, and spring-loaded hinges for that. And then the 70 centimeter antenna folds out from underneath the solar panels. The electronic boards we are using, for the most part, proven electronic technology from AMSAT. We are not reinventing the wheel here. Working with Alan Johnson and some of the other people on the AMSAT group, we're to the largest extent possible using what's already been proven, and so that's working out well. We are working with several different experimental VLF receivers, one of which is based on a Canadian supplied chip that's used for time WWVB receiver. It's based on an MAS 6180C chip. VLF receiver on a chip, basically. That's one of our candidates. We're looking at some of the other ARRL circuitry, and as I mentioned, David Fields and his group in Knoxville have a candidate receiver as well. So we hope to finalize our science experiment first part of the year and get additional testing done on that. This is basically what the satellite looks like once the panels are deployed and the antenna is deployed. So we are a little bit past 50% in our development and build. A drawing pretty much a drawing package of the mechanical hardware is done. We've done a good bit of the electrical buildup and beginning testing here based on the AMSAT circuitry. We're going to demonstrate a 1-unit simulator, and which is based again on AMSAT technology. We have it will be a fully functional form, fit, and function engineering model and integration aid, hopefully ready to go into environmental testing first part of the year, and we've got that to show you today. And as I mentioned, we're lining up cooperation with several people on testing. I don't expect you to be able to read this, but this is our schedule. I've broken it down into more readable things, and we're actually working with some of our project management people here. Had one of our students just about a week ago helped update some of the Microsoft project scheduling and such. So we're using that to the greatest extent possible. And the way it's looking now, the project will exist on throughout the end of 2024 and possibly into 2025, depending on how long the spacecraft will be in orbit. And that's one of the things that we're negotiating and collaborating with Via Space on. That's one of the topics of our meeting on Tuesday, is to discuss what their latest thoughts are there. They have just finalized negotiations with their primary customer for the launch that we're manifested on. So we do not have a data dump yet on what they agreed to and on their orbital parameters. So that's what we're going to find out hopefully this coming week. So to recap that, CubeSats, as you all know, and I know Rich has been involved with them, many of you probably have worked on other CubeSat projects. We were lucky to be able to interface with Bob Twiggs, who was one of the original co-founders of the CubeSat project. I worked with Bob years ago on the first commercial launch from Cape Canaveral Air Force Station, which is now Cape Canaveral Space Force Station. It's been renamed. So we've had a lot of help from people who are very experienced in the CubeSat area. Again, we're going to be listening to VLF signals. If we can pick up something and make sense out of it, that is wonderful. That's our science experiment, but it is not the #1 priority. Building and launching the satellite is our #1 objective, and involving students in the process of that. If we're able to hear something very interesting in the VLF frequency range, that'll be icing on the cake. We've got the agreement signed with Via for the launch, and we've done about 50% of what we need to do. And I forgot that this side is upside down on the slides, but anyway, this is a logo from one of our contributors, our Central Alabama Community College group down in Alexander City, Alabama, home of the who is the big clothing manufacturer that does all of Auburn's? Oh gosh. Yeah. Anyway, they're well known, except that it escapes me right now. But anyways, Alexander City group, we've got them scattered everywhere, and are very lucky to have so many people contributing. So if I can get back to stop sharing my screen here, we will do some of our demonstrations. There's Brandy. Hi, Brandy. Brandy is our program director. As I mentioned, she is an employee from Aerojet Rocketdyne. She's been really busy lately, as you can probably imagine, but I'm glad she could join us. And let's see, meeting control. Oh, there they are. Okay, I'm gonna
The look right piece right here.
stop sharing. Okay, there we are. Any questions at this point? If not, we'll just go right into the demo. We've got several pieces of hardware to demonstrate for you here. And any questions?
What is the actual frequency range of the VLF receiver?
We're looking at between like 10 kilohertz and probably 200 kilohertz. I suspect we're going to settle in around 80 to 100 kilohertz.
What's your effect? What's the effective sensitivity of what you're doing there, and why are you using? Why aren't you using ferrite bars antennas instead of those small 70 centimeter antennas?
Well, the 70 centimeter antennas are for the UHF downlink transmitter. We are using ferrite core antennas for the VLF receiver. And here's an example of one of the little 60 kilohertz antennas we're looking at. We've also been looking at toroid type antennas. We're reviewing some declassified CIA information on that right now. So we'll figure out how that works out. But to answer your question, yes, we are using ferrite core antennas for the VLF receiver. Yes, ma'am.
Thank you very much.
Absolutely. Good question.
Wendy had a question on chat, and that is, what's the gender and ethnic breakdown of your students and staff?
Very varied. We have a large portion of our students and staff are either women and minorities or both. So we have a very diverse group, not only of people here at the university, but amongst our voluntary organizations.
Well, I'm glad to hear it. When I think back how things were when I was a young student, I probably would have killed someone to get into a program like yours.
Oh,
So especially these days, it's so nice to hear.
oh, absolutely. Well, as you can see, our program director happens to be a very capable young lady. And as a matter of fact, our chief engineer is a young lady, a woman who works out of the aerospace industry in Huntsville. We've got several other people, students that are female and different ethnic groups as well. So yes, I agree. And every time we get a group of students together, we get that comment, particularly from the faculty that support them, oh my gosh, what I would have given to have this opportunity when I was a youngster or a young student. And I agree with that 100%. Wow. But we're very happy to have the opportunity now. And as I pointed out several times, that is our primary objective here, is to get students of all ages from kindergarten all the way through college involved in some way to the greatest extent possible in our project, to tickle their interest in STEM and particularly space related STEM activities.
Well,
Jay,
let's hope.
good to
Let's
see
hope.
you.
Yeah, let's hope your example feeds back to NASA, because they still have a problem with hiring minorities in particular.
Well, I couldn't speak to that personally, obviously, but I know that one of our NASA supporters, Vicky, one of Brandy's friends, is a PhD over at NASA. She's lending her expertise to the project, but I'm sure there's room for improvement in that area everywhere, I think. Any other questions?
Yeah, I hate to hog up the floor, but what's the sensitivity of that receiver? So now that you've given me the antenna, I need to know what that's looking into.
I don't have those numbers right in front of me, but I'll be glad to to round that up and get it to you, Sarah. No problem there.
I'll
Like-
send you an email and you can just at your leisure hunt
Oh,
it down and
absolutely.
just flip it around back to me. Thank you very much. I
Yes, ma'am.
appreciate it a lot.
Be glad to do that. And listen, any of you, this is where we originated the mission. It's the scientific mission came from Sarah. So if any or all of you have ideas and are interested in contributing to that part of the project, or any part for that matter, but particularly in the radio astronomy aspect of the science experiment, we would love to have your help. So, okay, let's see.
There you go. 0.4 microvolt.
Yeah, David was just showing me some of the specs on it here, and this is not.
That's on that chip.
Yeah, this is the receiver chip. The one I can't speak to Dr. Field's receiver sensitivity, but the one we're looking at is 0.4 microvolts RMS typical. But anyways, okay. And Jay, where did Jay go?
I'm right here.
Oh, there he is. Hi, Jay. Well, I haven't seen you since we were trying to bounce signals off of meteor trails here a few years ago. So it's good to see you again, sir.
Yeah, and likewise. Outstanding presentation, Wayne. That was really good. And I lost feed there for a while. Rich has lost internet and electric power to his location. So I'll be taking over as moderator, and Ted Klein is meeting host until Rich returns. So did you have more demonstrations, Wayne? That was a great presentation.
Thank you very much. Yes, sir, we do. I'm going to turn it over to David Osley here. He's our technical director, and he's going to tell you, we've got two different things. This is our engineering model and integration aid. This is a full-size prototype of our satellite. You see the power supply, the battery pack here, all of the electronic boards are here. Does not have the receiver board installed, and it doesn't have the solar panels and the antennas, but we're getting this ready to begin testing. So we have that. It's fully functional in terms of the radio transmitter section of it. And David is going to take over now and show you where we are with the use of MSAT technology on the electronic part. We have a 1-unit version. Some of you who are familiar with MSAT have seen one of these. One of the things that we've done is to build the MSAT CubeSat simulator. And so this is a 1-unit, and we basically adopted some of that technology for our main electronics in our CubeSat. But go ahead, David, I'll hush.
Okay. We'll jump in anytime, since I'll probably sink here before too long. No, I'm David Osley. I'm a former student here at Athens State many years ago. I retired, obviously, from my career as an instrument technician with international papers. So I still know how to use a soldering iron. So that was the reason. And also a ham radio guy that's the last couple of years been very interested in satellite communication. So I've got a fully functional satellite transmit and receive station at my home. But Dr. Wayne and I have been friends for a long time. So when he offered the chance to jump on board and bring my soldering iron, I jumped at the chance. So it's been a great ride so far the last few months working with these kids, especially. And let's see, Sarah, I believe you were the one asking about the gender. I noticed the kids that we met with, the students we met with down in Cocoa that were from Brazil, over half of them were female. 80%. And 80%. Okay. Because I knew those girls just crowded around. They were so interested in this little CubeSat simulator, mainly because it has a camera. And so we can go into slow scan TV mode, and we got pictures of all these students. And they were very interested in how the Arduino little microcontroller worked. The Arduino does the payload monitoring, as far as we've got a gyro, we've got temperature, let's see what else, atmospheric conditions, altitude, that sort of thing. All of that is controlled with an Arduino, which goes to a Raspberry Pi. Well, these kids were interested in robotics and they were familiar with the Raspberry Pi. So they latched onto this little CubeSat simulator, but the ladies in this group were the ones that were really interested in it. And so, and even this group that we met with last week at the 3rd grade group, there was several of the young ladies had some very probing questions.
More girls than boys.
Yeah, I think we've got the gender thing, and as far as the racial makeup, I think that's pretty balanced too, as far as what in our school systems. But the ladies in the group was really interested in this, and I think we're going to have some good things coming in the future years. So as us old gray-haired guys retire and move on, there's going to be a lot of folks to take our places. But now we've had fun playing with this with the kids, showing them how a CubeSat works, what it is. We printed all this frame out here at Athens State, and I'm going to let Ryan, our student team member here, talk about how they printed the frame for the EMEA, the engineering model that we've got. But all this was printed here. I did most of the soldering on this, but we're going to try to migrate that into some of these students doing some of the work as far as building these boards. This one though has 3 boards, makes the components, got a battery supply, charging circuits, and power monitoring circuits. We've got a payload board that has all the sensors that I just described. We monitor voltage and current coming from all of the solar cells as well as the battery, so we can tell the health of the power system. We know if there's tumbling. We've got a gyro in there tells us the rate of tumble. As far as the temperature, we got, I think, 5 things that we sense. All that is we can read that in some open source software. I've got it running on a laptop, so you can't see that, but there's all of those parameters are being monitored there. And it does transmit on the UHF amateur radio frequencies. This one happens to be on 434.9 in the ham radio band. And so we're transmitting there. We're receiving it on this little $30 SDR RTL dongle. So very inexpensive to get into this as far as a receiving station. So we're setting up some of these receiving stations for the students and teaching them a little bit about radio technology also. One thing we did with the students the other day that got a lot of participation was building a Yagi antenna, a 5-element beam antenna for the UHF radio frequency that they could actually use to receive satellite signals. So we gave them a little handheld radio. Those of you that may be ham radio guys and gals, these are the Baofeng $20 radios you can get off of Amazon. So we programmed one of these where it would not transmit, it would only receive. And so we left it with them and pre-programmed it for the amateur satellites that are up there that they can receive with this radio and their homemade handheld Yagi antenna. So that's just some of the things we've been doing. And like I say, we've got a fully functional model of the CubeSat sim. The same board set is right now in our engineering aid. And so we're going to be adding to that with this VLF receiver and integrating that through software to be able to monitor the signals there. So
Why don't you crank it up and get it to send some telemetry of some
let's
kind?
see. Well, we can do the Morse code thing, I think, with the this is actually it'll have to reboot. You'll hear it has a Morse code mode and then an APRS, which gives you location information. There's the CWID. So we've got a CW mode that will use that as a beacon as it's floating in orbit. We can identify our satellite. And I'm sure most of you are familiar with APRS. It's it was developed by, what's the guy's name? He lived here in Alabama. Anyway, there's a ham radio operator that uses GPS signals and encodes that into a radio signal where you can tell positions of objects. It's in use all over the world now on radios. So from that signal, we'll be able to tell the location of the satellite, the altitude of the satellite, speed, and all this is related to the ground. I'm not sure how that's going to work in outer space, but we'll at least be able to tell some of the health of the satellite too. But that's one of the modes. I'm just going to switch gears again to this is BPSK. And this is the one that we actually read the battery voltage, the battery current, solar cell output.
While he's waiting for that to boot up, this is one of the little handouts that we gave to the students last week that shows how to build the antenna. And we went through the basic conversation about how does a satellite work? How does a satellite stay in orbit? What's the basic orbital parameters that the StemSat's going to experience and so forth?
I don't know if this will focus enough to, no, it's going to wash out. Isn't it? This particular mode is what we use to read with the telemetry decoding program. That's the BPSK signal. It's sending that information. And all of this code is open source. So we're as Dr. Wayne said a while ago, we're not reinventing the wheel. We're using some stuff that people have already developed, and we're adding ours to it and customizing it to use in our particular situation. But
do the slow scan picture. We'll take a picture of you holding the.
Okay.
I'll hold the satellite.
Satellite. All right, this is the slow scan TV mode.
We do expect to have a camera on board. As you guys know, you have to get special State Department approval to fly any camera that looks back at the Earth. And so our guys at Via Space will have cameras that are looking at various parts of their rocket during the flight. And so they've agreed to include our camera as part of their application process.
We're going to decode the slow scan TV signal with an iPhone, with an app running on an iPhone. So let's see. Maybe you can see the picture developing there. Maybe you can see the image beginning to develop. It's actually this is an internal stored image of the CubeSat sim itself. But this mode has been really effective with the students to show them how the satellite can work and actually send pictures from space. And we let them track it around the classroom the other day with their antenna that they just built. We moved the satellite around, let it take pictures of the students while it was. But there's an image of the satellite itself. That's going to take a picture of. He's going to get a picture of me. Yeah. Okay. See another image coming over now.
So it's already taken the picture.
It took the picture. It just takes a while to send it.
It's transmitting it now.
Gentlemen, I have a quick question.
Yes, sir.
While it's developing there, you went from a 1 unit to a 3 unit for room for bigger antennas, solar cell, and batteries, or what?
Some of all the above. The people at Moorhead have launched, I don't know, several dozen CubeSats over the last few years. And one of their comments was that for the long term, you would be better off to have a 3-unit size spacecraft, although it wasn't totally filled up. You would have room for expansion on future payloads and experiments and so forth. The 1-unit size here is so limited as in terms of the solar panel size and the battery capacity that there's just so much more to be gained from the 3-unit size. So our current spacecraft will have some voids inside the frame. It will not be totally full of hardware, but that will give us some expansion room for future spacecraft, we think. So that's our thinking. But instead of having a 3 or 4 watt, we're going to have a 10 watt plus sized battery pack, and we've got fairly large size solar collection area and capability there. So, and plus we weren't limited by our launch provider as to what size we could go with. So that gave us an opportunity to go for a 3U.
And here's my ugly mug that it just took a picture of. So like I say, that mode is really effective with the students, the younger students in high school age and below really enjoy taking pictures of themselves. Everybody likes to take selfies. So they can see the satellite do that and actually track the satellite as it moves around the classroom and takes pictures of everyone. So any questions about, that's basically what we got as a STEM demo. And we've taken that technology, actually those very boards, and moved that into our engineering model here that we're building to incorporate the VLF receiver and, like Dr. Wayne said, the bigger battery packs and stronger power supply and solar cells.
Now the spacecraft will be somewhat tumbling, although I hear something about orientation a bit by gravity.
Right.
And you're going to take a quick enough picture, I suppose, that it doesn't blur, is the hope, and then send down that still, correct?
That will be one of our options. We really haven't decided yet on how we're going to parse all that data. We have several different modes available, and one of them will be the slow scan TV. So we'll probably cycle through the different data types on any given pass, and but we're not going to depend on getting a clear image of anything terrestrial from our camera. Our little camera has such limited resolution that you know, you probably be able to tell that it's Earth, and that's about it.
Will the spacecraft be receiving commands, or is it programmed already once it goes up?
It will be totally autonomous. No command capability will be built into it. So we're not going to communicate to it. It's going to be pre-programmed, autonomous.
Dr. Wayne, can you show our solar panels that we have?
Oh yeah, that's one of the things we could do. This is the size of our solar panel. This is a prototype, but we will have 4 of those panels that deploy at the top end of the satellite, as you saw in the picture. So there'll be,
We can see it.
yeah,
So 4 on.
yeah, 4 of them like that.
And we're considering putting solar panels on solar panels on the sides as well. So even if it's, possibility. Yeah.
Are those panels any more efficient than what you typically purchase, the 15–17%?
No, sir, that's what they are. Yeah, we one of the things that's going for us, I guess, is that we have an overabundance of solar power collection capability that we will not suffer greatly from the lower efficiency cells. So You might be interested in what we're going to be doing with the grant we're receiving from Sarah. Up until this point, all of our development expenses and travel, what hasn't been covered by the university, has pretty much been our lunch money. But we will be using this grant money to build the actual flight hardware. So it will go to extremely good use. And of course, we have the capability, and we'll report back to Sarah on how the grant is expended. So we really appreciate the help and continue to work with Sarah. And as I said earlier, if some of you have ideas and contributions you're able to make to the science experiment part of it, the radio astronomy scientific mission, we would love that.
Let me make a comment about the power. I worked on several of these satellites myself earlier. Actually, I worked with Bob Twiggs at the very beginning. But I think there's a great opportunity for an educational benefit of talking about the power that you have available to you from the solar cells, and to have like an exercise where you look at the exposed surface area, the efficiency of the cell, the anticipated energy that the sun is going to provide, and orientation problems, and then talking about the amount of current that you're going to consume on the satellite itself, and the fact that you're going to charge batteries, and batteries have a certain amp hour capacity, and then relate that back to someone's home. And you have so many people interested these days in putting up solar panels.
Right.
And I'm talking to the local electrical people here about this issue a little bit, and they don't, the salesmen are selling people on the solar cells for their roof that won't anywhere near support their home, but they're thinking they're going to get a full off the grid situation when they get these installed. So it's a great opportunity at a young age to teach people. It's almost it's a green technology thing too. So I think there's a gold mine of opportunity there from the educational point of view.
Boy, I agree with you. As a matter of fact, we talked with our Spark Academy instructor last Wednesday when we made the presentation this past Wednesday. And that's one of the questions the students had. They did want to, can we take the satellite outside and measure the voltage coming from the solar cells? And that brings up a good point. We are looking for volunteers to help us develop lesson plans to present to the STEM students at various educational levels. And what you mentioned there, Bob, would be an excellent lesson plan. And I don't know that you're able or prepared to work on something like that, but if you were, or if you can get a group of people together to work up a lesson plan just on that one particular technology, that would be awesome, and we would welcome that. And I agree with you, it's a great opportunity, because it's like so many other things that get oversold. The technology's there, but it's not necessarily cure-all. It's not going to solve all of our energy and pollution, global warming problems just by going to solar cells. So excellent.
It also needs to drive your thought process too on what you're going to put on this satellite and how it's going to work.
Exactly.
Because as you pick your components, I've been in lots of programs where people over-engineer things, and you might pick out a certain processor or capability that it's really not needed in the scenario you have, but it draws a lot of current, and you're going to, if you go and look at a lot of the CubeSats today, many of them have to be shut down for a great deal of their orbit, or for periods of time to be recharging. So you end up losing, you're not going to be up there that long in the long run anyway. So you want to maximize your own time.
Yeah, we had the several AMSAT volunteers were at the Huntsville Ham Fest back in August, and Brandy and I sat in on several of the presentations that discussed the late current pretty much mission duration of typical CubeSats. And I don't remember the gentleman's name who made the presentation, but he's one of the AMSAT top guys. Anyway, he's saying that, I mean, they're looking at 4 to 6 weeks as a mission time. And I know it's controlled obviously by the orbital parameters that are made available. So that's one of the things we're going to be discussing with our launch provider and see what can we anticipate in terms of duration, what might be the service life of our satellite, and within that boundary, what are the things we should do and can do.
Well, you also could fill up that empty space you have with weight, and that it creates what they call ballast. But
Right.
you're supposed
Exactly.
to also have a deorbiting plan for the satellite too. I don't know if you're working on that as well, but
It hasn't come to the forefront yet, but I'm sure it will have to be addressed. You're right. We've got lots of things to do yet.
So do you need in your program, well, the students are pretty much doing all the listening to the satellite. I mean, there's a fancy word for that. It just escapes me now, but do you have any need for a station to listen to your satellite?
Always.
You do?
Always. Yes, ma'am.
All right. Well, that's interesting. That conjures up some thought processes there. Let me
Good.
put my
Good. We would
cap
love
on.
it. Yeah. My opinion is you can never have enough listeners. You never have too many listeners anyway. So Rich was just talking about coming up with a configuration of his 60 foot, 60, is it 60 feet or 60 meters? 60 feet.
60 foot.
60-foot diameter dish out there. And yeah, apparently he's done some similar work several years ago with the CubeSat project. So yes, absolutely.
Well, we have a tiny little radio telescope at the University of Maryland with a very heavy back end, small dish though, you know,
Right.
but we use Tektronix spectrum analyzers for our receivers. So we're down to, and really, really great preamps on it. So we're down to like minus 170 dB. So we would very much be interested in picking up problems. We have some political problems we have to overcome, but just marrying up with you guys would probably give us a little bit of horsepower to get past our little political problems.
We would love that.
Okay, let's see what we can do.
Yes, ma'am. Absolutely.
Okay.
Count us in.
One of the things that we have right now that we're doing with the students is we have an antenna receiving kit. Basically, for $100, they can put this together. It can be one of the lesson plans that they do, and we have those instructions put together, and they're able to build their own little listening antenna that they could start using now, you know, with a little handheld radio.
Yeah, that's a great idea, Sarah. We'd love to work with you. Well, that's really all we had formally today, and
Red box.
yeah, say a few words, Ryan, if you'd like. Ryan came from the student design group that originally designed the 3D printed frame here. I'm going to move out of the way so you can see Ryan back here, but
I don't take up too much time. There's not really a lot left to talk about, but I can kind of briefly go over this. As they said, my name's Ryan Frost. I came from Calhoun Community College. I'm now here at Athens State. The full team that worked on this design project was Brandy Wheeler, who is also in the call here, William Schmiegel, and myself. We designed out the outer frame here you see in red for the EMEA prototype through many different iterations and prototypes that we made of the outer frame to our current design we have here. It was fully 3D printed in PLA, so standard filament that most 3D printers use for pretty much any project you can do. Your red box too over there. We had a prototype for our P-pod that we were using at the time for sizing to make sure everything would work out and fit. We're going to be working on designing a new P-pod frame, as Dr. Wayne said earlier. We're hoping to partner with Calhoun on that. Again, we partnered with them last semester, I believe it was, for designing our battery box down here at the bottom, that we need to do a print on our frame for that, so we can try to get as much of our components 3D printed to make this a relatively inexpensive cube that can be launched.
Well, we just appreciate the opportunity to speak to you all, and certainly appreciate the involvement of Sarah in our project. And you guys were the inspiration for it in the beginning, and certainly are a major component collaborator as we go forth. So thank you for the opportunity.
Great. Thank you, Wayne, and the whole group.
Yes, sir, Rich. I'm glad to see you back.
I could have used those solar panels about a half hour ago.
What happened? How the hell how
just the whole block went down. The whole block went down in power for some reason.
Wow.
So, yeah, great job. And by the way, this is fully compatible, appears to be fully compatible with the current AMSAT systems. So anybody has a ground station, AMSAT ground station, I've got one here because I used to do Colorado University AMSATs. It'll work, and we can actually have the AMSAT ground stations can be remoted, so that Wayne and his team can actually control your AMSAT ground station and listen in wherever you are in the world. So anybody interested in setting up an AMSAT ground, and by the way, you just need a Yagi. It's a UHF Yagi since they're not transmitting, and you need to have it on a three-axis antenna system. So you don't need a 60-foot dish for this. That's a little overkill, or but I have a 13-element Yagi that I use for AMSATs. It works fine. It should work with this one, and a simple software package. So anyway, the other thing I was going to comment on, have you had your 3D printed frame shock and vibration tested? Because that's it has to be able to survive launch, and that might be something you need to do before you get too far finalizing it. You don't want it to crunch during launch. So.
Yes, sir. That's on our schedule for January, is to begin that kind of testing. Absolutely.
Great.
We're working with Dynetics locally, and also Adtran. You may have not heard of Adtran, but they are a technology innovator in our area. So we're working with them and hope to start in January. So shake, rattle, and roll, and shock.
If anybody wants to volunteer, how do they get a hold of you?
Well, just my email address is pretty easy to remember. It's just drwayne@athens.edu. I was in the right place at the wrong time. I actually established our first hosting address here at Athens State when we began our email system and internet presence. So I get to have whatever I want for my email address. So anyway, just drwayne@athens.edu, and would be glad to hear from any of you and solicit your ideas and help for sure. Thank you.
Great. Any other questions?
Is there a website, Wayne?
Currently there's not a dedicated website for the StemSat. That's something we need to do. We do have a university website that mentions it as part of our new degree program. If you go to athens.edu/ASM, which stands for Aerospace Systems Management, at the very end of that description of that new degree program, there's a little blurb about our satellite project, and but we do need to make a website for sure. should be on our list of things to do. I agree.
Thank you.
Yes, sir. Thank you all. Thank
This,
you.
oh, I had one
Oh.
comment. I think the old Vela satellites also have HF or VLF outputs, and I don't know if they're still active or not. I suspect they are. So there may be a way to check on your signals.
Oh, that's awesome. All right. Well, did you hear that, David? We need to get the information on it. If you get a chance and have.
I haven't got any further, but they're on the web. It's the VELA. It's one of the first fleet of a few sniffers for nuclear explosions in the atmosphere. Way back, way old stuff. And I think they're still pooping along generating data, as far as I know. So you might just look it up and see. It'd take about 2 minutes to do.
We will do that. Thank you so much.
You bet.
My understanding is the ISS also has an APRS ham radio station on there that you might be able to listen to and get APRS down from it.
I've been doing that. Let me get back in the picture here.
Great.
Like I said, I've got a VHF, UHF tracking station at my home, and so I've been doing two-way communication through the satellites as far as talking to other hams, and also listening to the APRS. And I've transmitted an APRS message through the ISS. Actually got a QSL card from the ISS, where I made a two-way conversation with them.
So something that might help this group if they want to get involved is can you document your ground station so that they could, maybe a couple of them can reproduce it and join in the ground station team.
Awesome. We'll do that. So one of the papers maybe we can present at the Western Conference or the Eastern Conference when it comes about. At the latest, we can do exactly that. Document the ground station information.
Yeah, that'd be great.
All right.
All right. Any other questions for Wayne and his team? All right. Thank you, guys. Good luck and keep in touch. And this is going to be fun.
Yes, sir. I agree. Thank you. We're looking forward to it.
Thank you.
Yeah.
Thank you very much for the opportunity.